Given 2 points A and B on a plane, how many circles pass through A and B? First you draw a circle. If A and B, 2 points on the circle, it has a center O, then the length of OA and OB are equal, because we know all points on the circle are equidistant from the center. Is there another point with this property? Yes. The midpoint of the segment AB. First you take a line segment AB, then find out its midpoint. Suppose here is the midpoint as M. Now with the midpoint as center, you have to draw a circle. Okay. With the midpoint as center, you draw a circle. Now see, this circle passes through the points A and B, where the radius is half of the length of AB and the diameter is length of AB, where radius is half of the length of AB and diameter is the length of AB. Are there more circles passing through both A and B? Yes, you can draw more circles passing through A and B. Suppose P is a point which is equidistant from the point A and B. Now, with P as a center, you can draw a circle which is passes through A and B, both the points. So, P is the center of this circle which is passes through the points A and B. Okay. Now, the question is, how do you find such points? We have seen that perpendicular bisector, okay, of the line segment AB is the locus of the points equidistant from A and B. If you take a line segment AB and draw a perpendicular bisector on AB. Okay. Now, if you take some points on this perpendicular bisector, all points are equidistant from A and B. You can draw more circles using these points as a center. Suppose I am taking this point name as Q. Now Q is the point which is equidistant from A and B. That means Q is the center of this circle. Now you draw a circle as a center Q. Here Q is the center of this circle. Now this circle is passes through the both points A and B. If you take this point as center, name it suppose S. So S is equidistant from A and B. So S is the center of another circle. So here in this circle, S is the center and which is passes through the point A and B. So in this way you can draw more circles which is passes through A and B. Let's see on the other side of the line segment AB, if you draw the perpendicular bisector like this way, and if you take some points on this bisector, suppose I am taking here and name it T. T is the equidistance from A and B, and now you take T as a center and draw a circle. So this circle has center T and which is passes through A and B, both the points. So here we have seen that you can draw more circles which are passes through both A and B points. If A, B and C are not collinear, is there always a circle passing through A, B and C? Take 3 points A, B, C. They are not collinear. That means they are not lying in a same straight line. Now if you draw a circle which is passes through these 3 points A, B and C as a center O. Since OA equals to OB, Why? Because in our previous theorem we have seen that if AB is a line segment and if you draw a perpendicular bisector of AB, now you see O point lies on this perpendicular bisector of AB. Similarly, since OA equals to OC, if you draw a line segment AC, okay, and if you draw a perpendicular bisector of AC, then you see O lies on this perpendicular bisector of AC. Now extend this to perpendicular bisector. Now you can see these two perpendicular bisector of AB and AC intersect at the point O. Now using O as a center and OA distance as a radius, you can draw a circle. Now see, this circle passes through all 3 points A, B and C. Similarly, if you join this BC and make a line segment and draw a perpendicular bisector of BC. Now this perpendicular bisector of BC also intersects the point O. That means this circle is passing through these all 3 points A, B, C, which are not collinear. Now you see these 3 non-collinear points also determine the triangle ABC, the center O of the circle that passes through these vertices of A, B and C of triangle ABC is called the circumcenter. That means this O is called the circumcenter. Okay, because this triangle ABC, the vertices of ABC, A, B and C, the center of the circle that passes through these vertices A, B and C. That's why this center is called the circumcenter, and the circle is called the circumcircle. This circle is called the circumcircle. Circumcircle. Okay, this is the circumcircle. The second part of this question is, can there be more than one circle through A, B and C? Since the intersecting point, this intersection point of the perpendicular bisector AB and BC, AB and BC, the intersecting point is a single point. O is a single point. There is no other intersecting point of AB and BC, only one single point. That's why we can draw only one circle through ABC non-collinear points. Okay, and you can see this triangle is called the acute angle triangle. When the triangle is created acute angle triangle, the center of the circle lies inside the circle. The center is the inside the circle. Okay. So in acute angle triangle, the circumcenter lies inside the triangle. And in obtuse angle triangle, circumcenter lies outside the triangle. Okay. And in right angle triangle, right angled triangle. The circumcenter lies at the midpoint of the hypotenuse. So in this figure, a right angle triangle has formed where the circumcenter lies at the midpoint of the hypotenuse AB. In right angle triangle ABC, the hypotenuse is AB, where the midpoint is O, and O is also a circumcenter of the circle. So in this figure, we get a obtuse angle triangle where the circumcenter O lies at the outside of the triangle ABC.